So welcome. My name is Natasha Lance. I'm the Executive Director at the T. Colin Campbell Center for Nutrition Studies, and otherwise known as CNS. And welcome to this evening's Spotlight on Health, Demystifying Nutrition. What are normal nutrient values? So this evening, we are joined by Dr. Milton Mills and Geoff Palmer, and will be hosted by Dr. Michael Hollie, who is the head of our medical advisory board at CNS. I'm going to go over a few housekeeping details to make everyone comfortable and know what's what and what we're going to do this evening. So the first thing is, if you need closed captioning, go to the bottom of your screen and there's a button that says CC. If you click on that, there will be closed captioning available to you. For those of you who are interested in the replay or might have to leave early, or you're thinking you're going to have to furiously take notes, don't worry. We will send everyone a replay 1 week from today, which is November 13th. Do check your spam folder because sometimes it does end up there, but you will receive a replay. For those of you who are interested in asking questions this evening, and I hope it's a lot of you, please put your questions in the chat. I will be compiling those questions, and then we will ask those at the Q&A at the end. So without further ado, I would love to hand it over to Dr. Hollie.
Thank you, Natasha. It's a pleasure to see so many people out there and from many places around the world. Welcome, everyone. You're going to be in for a treat tonight with Dr. Milton Mills and Geoff Palmer, talking about a lot of things that you may be interested in. Dr. Mills is going to talk about protein and dairy and iron and fiber, and Geoff's going to talk about omegas. He's an expert on the omega science, so we'll look forward to that as well. So Dr. Milton Mills practices outpatient clinic-based medicine in underserved communities in the Washington, D.C. metro area. Dr. Mills is the medical director for the United States Census Bureau in Suitland, Maryland. He is also the founder and president of Physicians for a Healthy America, an organization of physicians of color focused on promoting the benefits of a plant-based diet. He graduated from Stanford University School of Medicine and completed residency training at UCSF, Fresno, and Georgetown University Hospital. He has lectured and given research seminars throughout North America, Ireland, and the United Kingdom on several preventive health topics, including the negative impacts of meat and dairy consumption on human health, nutrition and HIV and AIDS, nutrition and cancer, and the dietary needs of various ethnic groups. Geoff Palmer, a 61-year-old, 40-year vegan, is a natural bodybuilding and natural physique masters champion, the owner of Clean Machine Plant-Based Fitness Nutrition. He's an author, national lecturer, vegan patent holder, and two-time NextD winner for Best Supplement of the Year. Geoff was selected number 40 of the top 100 most influential vegans by Plant-Based News. Geoff created the first all-vegan natural bodybuilding competition in the world. He has the last 30-plus years been researching omega-3 nutrition and is currently working on a book to publish the findings. Welcome, Milton. Welcome, Geoff. Glad to have you both here.
Thank you.
Thank you for having me.
Thank you. CNS, is an honor to be asked to do this presentation tonight, and it's a topic that is near and dear to my heart, and I believe that everyone will get a lot out of what we're going to discuss. I just want everyone to understand that this topic is as broad as the Pacific Ocean, and we're only going to sort of skim the surface of a small portion of it tonight, but we're going to talk about it in ways that I think will help people frame this subject appropriately and not be terrified when they go see non-vegan practitioners who set the hair on fire because their values are not what they're used to seeing. So with that, I guess I can go ahead and hit screen share and get started. Is that correct?
Yes.
All right. So you should be seeing all of my slides on the screen. Is that correct?
Correct. We see all the slides. Yes.
Okay, so, and then now you see a big blue background with some periodic table elements. So let me just give a little provenance as to what led me to develop this particular lecture. Time and time again, I would hear from plant-based patients or friends or church members that they went to their physician and the physician said, "Oh my God, your ferritin and iron levels are so low, you're at risk of becoming anemic." Now they weren't anemic, but the doctor was terrified because they were, quote, at risk, which no, they weren't, and they aren't. And so I, tried to help them understand why their iron levels are low, because the body doesn't want a lot of iron floating around, and that was normal when you're plant-based. I just recently spoke with a patient that I saw beginning of last year, came in with diabetes wildly out of control. Fasting blood sugar was 263, A1C was 9.8. To just give you the quick and dirty story, he went completely whole food plant-based, and within 2.5 months, his A1C had come down to 5.6, fasting blood sugar was normal, and all of his cholesterol values were within normal range. I spoke with another patient of mine that I had been seeing out at the Stumfries Clinic, who I've convinced to adopt a plant-based diet, eliminate dairy. He went to see one of my colleagues, and his total cholesterol was, I think, 136, and the doctor told him that there was something wrong with him. And I assured him that no, in fact, that was exactly what one would want to see. But these are the kind of problems that happen when people see practitioners who don't understand how the body changes when we adopt a plant-based diet. So with that, let's go ahead and get started. This is an installment in my lecture series, Chemistry for Understanding Nutrition. We are going to be looking at normal values for plant-based populations, or nutrients in normal values. And the subtitle of the talk is, what is normal? What is needed? And finally, what is good? And I will like quoting this text from Proverbs. It says, with all you're getting, get understanding, because I believe in trying to help people understand the principles of health so that they don't have to walk around with a mental or literal list of do's and don'ts, but they actually have the tools to analyze any novel situation they find themselves in and make good choices. So, and again, thinking about this lecture, and I tried to figure out, so what topics am I going to discuss? And I thought about what I would discuss and what I wanted to discuss, and it quickly became apparent that there wasn't. Oh my gosh. Are you guys still seeing my slides? Because my computer freaked out. Can you see me?
It's black now. It's a black screen, Milton.
Oh boy. Okay. Are we back?
Yes, you're back.
Yeah, boy. I'm not sure what happened. All right. So I thought about what I would discuss. Again, too broad. So I then pared it down and thought about what I could reasonably discuss within the time allotted, and that would include working with my very good friend Geoff on what I consider to be an incredibly important topic, and that is omega-3s. But then I realized that I can't just discuss these things without any context. So that led me to what I should discuss. And to correctly understand human nutrition, we have to have an understanding of the basics of nutrition science. And that's why, again, I originally created my lecture series, Chemistry for Understanding Nutrition, so that people could understand carbohydrates, proteins, fats, and so on and so forth. In deciding how to craft this particular lecture, I realized that it would be confusing and potentially misleading to try to discuss, quote, normal physiologic values for people without providing the proper context and dietary theory, because it's impossible to get to a correct destination if you never get off the wrong road. So this leads me to the question, what are humans supposed to eat? And this chart that is coming up is just a brief overview. And what it's meant to show you in a concise format is that humans are adapted for a strictly plant-based diet. I'm not going to spend a lot of time on this topic because I have a whole lecture called Are Humans Designed to Eat Meat that you can find on my website or on YouTube that explains that we have the anatomy and physiology of committed plant eaters. And that's important because it means that our bodies handle nutrients and foodstuffs differently from animals that are designed to eat other things. So I gotta minimize. All right. So, well, we can't understand, again, human physiology, how its physiology is supposed to work if we don't know what we are designed to eat. I'm trying to get the, jeez. I apologize, but this window over on the side is taking up too much. Okay, there we go. All right. So here are some just quick examples that really underscore how human beings are strict plant eaters. Vitamin C metabolism is critical for all higher organisms, and the vast majority of vertebrates and invertebrates actually make their own vitamin C because it is necessary for making collagen, and collagen is literally the stuff that holds our bodies together. And we need it in large amounts, and we need it every single day because we don't store it. And if we don't have it, our bodies literally begin to melt. Our tendons start to come apart, our scars dehisce, and we develop this disease called scurvy, which is kind of like melting. And if it's not corrected, you will quickly end up dying. And throughout history, millions of people have died from a lack of vitamin C. And again, the majority of extant species are able to make their own vitamin C. So how is it that humans and a few other animals were able to live and prosper without being able to make this? Clearly, it's because they were eating a diet that contained copious amounts of vitamin C on a daily basis. And that's a plant-based diet because there is no vitamin C in animal foods. So that's one thing. Then it comes to potassium versus sodium handling in humans. Our kidneys are excellent in being able to get rid of potassium. And that's important because potassium is the primary cation in plant foods, and there's tons of it. And if you don't keep the blood potassium level within narrow parameters, it will cause the heart to stop and people will die. So our kidneys excrete potassium, but what you don't find in large amounts in plant foods is sodium. Sodium is found in very low levels, which is why all animals that are plant-based have a taste for salt, a desire to eat salt, and will search out salt licks and so forth so that they can keep their body replete. And in some unfortunate studies that were done in Russia in the 1950s, they took carnivores like dogs and artificially depleted their dog chow of sodium, and they would put out the dog chow and right next to it a little bowl of salt, and let the dogs eat at at will, and the dogs would come out, dutifully eat their chow, never touch the sodium until they died from hyponatremia or low sodium levels, because they didn't have a mechanism to tell them to seek salt. Why? Well, if you've ever cut your finger and stuck it in your mouth, you know why. Blood is full of salt. And if they are carnivore and they're alive, that means they're eating other animals, so they're getting tons of sodium. They don't need a mechanism to tell them to seek sodium. But we do, because it is not found in high amounts in plant foods. And then finally, human jaw structure and mechanics. We have a jaw joint that is above the plane of our cheek teeth. And I explained in the lecture, Our Humans Designed to Eat Meat, that is believed by anatomists to have evolved 15 different times independently throughout mammalian evolution, because it is so critical and key to digesting plant foodstuffs. And it is only found in strict, committed plant eaters, because if a meat eater tries with, or if a plant eater with that type of jaw structure tried to kill and eat an animal, they would dislocate their jaw and end up dying from starvation. So the other important thing to realize is that in nature, organisms have to be energy efficient. They don't waste energy on biological processes that don't serve any use. So for instance, troglobites are animals that have been trapped in cave systems where there's no light, and over generations, they relatively quickly literally lose their eyes. They become, they stop making eyes and expending all that energy creating these very complicated organs, and learn to navigate in different ways. And they use that energy for something else. And that's, again, because in a competitive environment, organisms cannot afford to expend energy on unneeded biological machinery. Nature's dictum is use it or lose it. And Geoff will go into more detail on that when he talks about the fact that we retain the ability to take 18-carbon omega-3 fatty acids and elongate them to EPA and DHA, which you don't find in meat eaters. And then biological adaptation can be relatively swift. So globally, the vast majority of humans and all mammals actually stop making an enzyme called lactase that digests milk sugar once we're weaned. However, dairying, which is the use of bovine and sheep milk to make things that humans can eat, has only existed about 3,000 to 5,000 years, although, and it's believed that the human species is over 100,000 years old. And it was invented in Northern European countries to provide calories to help survive winter months and lean times. Yet within this very short period of time, up to 70% or more of Northern Europeans have evolved to be lactase persisters. That is, to continue making this enzyme throughout their lifetime, because it was so important for being able to get the energy that they needed to make it through the winter. So my point in pointing these things out is that there really has not been any adaptation in humans to consuming animal tissue. And even the phenomenon of lactase persistence, meaning that we didn't acquire new enzymes, it's just that over time they selected for people who continued to make that enzyme throughout their lifetime. While that allowed them to extract energy from the dairy products, it did nothing to change their physiology and ameliorate the damage that's caused from ingesting animal protein and animal fat. And that's why dairy is associated with so much disease. So what we are seeing now around the globe is that as countries industrialize, westernize their diet with more animal and processed foods, it correlates with increases in allergies, autoimmune and chronic diseases, and psychiatric disorders like depression and anxiety. Asthma has increased tenfold in Western countries between 1960 and 2000. Since the 1950s, type 1 diabetes, multiple sclerosis, and Crohn's disease have increased by over 300%. Breast cancer rates in the United States have increased 8% in women under 40 over the last 10 years, which is frightening. And colon cancer rates have increased by 9% in people under 55 years of age between 1995 and 2015. And the colon cancer rates are believed to be continuing to increase by about 2% per year. And so the bottom line is that all the major diseases and death in Western countries result from our animal food-centric diet. We don't need animal foods. It deranges our physiology and ultimately creates disease. All of these heart disease, cancers, diabetes, asthma, strokes, obesity, autoimmune diseases are preventable by changing to a plant-based diet because these things are plagues of our own making. So let's talk about, well, what do we need? Well, that's where the U.S. Recommended daily allowances come in. And bottom line is they start with an estimated average requirement, which should meet the need of about 50% of the population, because we're all a little bit different. Then they go 2 standard deviations to the right of that to get the RDA. So the RDA is designed to meet the nutritional needs of 97.5% of our population. Now, let's talk about protein. Where do you get your protein? And the need to discuss this topic became clear to me last week when one of my colleagues, who is a critical care physician, which means she's very well educated, we were talking and she said, "Oh yeah, you're a total vegetarian." I said, "Yeah, no meat, no dairy." She said, "Well, is protein an issue?" And I just almost fell off my chair. So what makes protein protein? Protein is notable for having the element nitrogen in it. The nitrogen comes from our air. However, atmospheric nitrogen is incredibly inert, and only plants working with bacteria can break that triple bond between the 2 nitrogen molecules, add electrons to the nitrogen to reduce it and make it chemically active so that it will bind to other molecules, and then they're attached to carbon backbones that are made by combining oxygen and water under the influence of sunlight. And these newly synthesized amino acids are then combined into the proteins that make up the tissues of all living things. So, fundamental point, all protein is initially made by plants. Okay, not an animal in the world that can break apart nitrogen and create de novo amino acids. And so let's see, I've covered this. So yeah, all amino acids and all protein is initially made by plants. Any protein that you get from an animal source is recycled plant protein. And all animal and plant protein are made up of the same 20 amino acids. And so someone might be thinking, wait a minute, how can you get such disparate tissues as muscles or skin or leaves and bark from the same 20 amino acids? And you see it says the alphabet in the Library of Congress. Our alphabet is only 24 letters long, but the Library of Congress contains millions of books by millions of authors, all different, but using just that limited number of letters. And it can be recombined in many novel ways. Same thing with these 20 amino acids. Major determinants of protein utilization, we need to get, I think the current recommendation is about 0.6 to 0.7 grams per kilogram per day. Make sure you're taking in enough energy on a daily basis, because if you are starving, your body's going to convert the protein into carbohydrate and burn it for energy. Make sure you have an adequate intake of essential amino acids, which is generally not a problem. Complementing proteins, that is combining foods to make sure you got all of the essential amino acids, is not necessary. Exercise improves the efficiency of protein utilization. On average, even people who follow plant-based diets get 70% more protein on a daily basis than they can use. So important points: protein can't be stored or burned for energy as protein. It has to be converted into carbohydrate. First, that's a process called gluconeogenesis. The nitrogen, sulfur is stripped off. The sulfur causes a weak acid, which can help leach calcium from our bones. And then the nitrogen is turned into urea, which has to be excreted by the kidneys, which causes us to lose a lot of water and can dehydrate us. And interestingly, carnivores can eat a high protein diet, get rid of all that excess protein without damaging their bones. We cannot. So how much protein is enough? And I wanted to include this because a few months ago, I saw this frantic post on Facebook where this woman said that, she was vegan and she got a new trainer and he told her she needed 105 grams of protein a day. And she was just frantic about how am I going to get that much protein on a plant-based diet? And I explained to her, you don't need that much protein because if when you factor that out, 105 grams, if we were using the 0.8 gram per kilogram per day, that should actually say 131 kilograms, would come out to be 289 pounds. She'd have to weigh 289 pounds to need that much protein. That's as much as a female gorilla needs on a daily basis. And clearly, you can't listen to people who don't understand the science behind nutrition because they will just tell you things that are utterly ludicrous. And there's always this question of, well, do people need more protein as they age? Because there's the specter of what's called sarcopenia or muscle loss. And I'm not convinced that people necessarily need more protein because the studies that I have been able to come across didn't control for activity, didn't control for exercise, didn't control for the type of protein that these participants were eating. So I'm not sure that data is accurate. And I'm not going to go running down the street chasing that shiny object if the science isn't good. So quick question. What do these animals eat? Plants, of course, right. So is there any point in their life where they eat animal protein? 80% of the people are going to say no, but 20% will say, hey, actually, yeah. When they're babies and drinking their mother's milk. And what that means is that animal protein is a potent growth signal and stimulant for human beings. And it turns out that early nutrition researchers thought more was better. And they saw that animal proteins contain more essential amino acids, the 8 that we can't make, than plant proteins. And so they said, that means the animal proteins are better. And then some even looked at the amino acid composition of different animal proteins and concluded that eggs actually have the closest sequence to human tissues. And that's why they deem eggs the perfect protein. But I'm like, hell, if we want proteins that are close to our own composition, why stop with eggs? I should just eat people. And that is just to point out how ludicrous the idea that you need to eat something that is similar in composition to you is. You don't need to eat eggs. You don't need to eat people. Again, it's a de facto argument for cannibalism. For herbivorous mammals, as I mentioned before, animal protein is a growth signal, a stimulant. It turns on these master regulatory genes called mTOR genes. And the mTOR genes stimulate proliferation, growth, and they should only be active when mammals are in their infancy. The amino acid that is primarily responsible for activating the mTOR genes is the essential amino acid leucine, which is found in much higher amounts in animal products people frequently eat. And that is the way that our body can tell whether we're getting our protein from a plant or an animal source. Decreasing animal protein intake decreases mTOR activity and also suppresses a growth hormone called insulin-like growth factor. Why would we want to do that? Because when you're an adult, your cells are supposed to be in a steady state. If you're constantly hitting them with a signal that's telling them to grow, and you're hitting them with hormones that stimulate growth, you are going to force those cells to start forming abnormal clumps of cells, which can be benign or malignant tumors. And mTOR genes are upregulated in human cancers, and those cancer cells are also covered with IGF-1 receptors. Studies show that vegans have 13% lower IGF levels than people who eat meat. And in a landmark 18-year study, they showed that people with the highest animal protein intake had 75% higher overall mortality and 4 times as much cancer. And this just will show you the leucine content of commonly eaten foodstuffs. So what the take-home message from this is that plant foods have more than enough leucine to keep us healthy, but not enough to flip on those mTOR cancer-causing genes. Again, you know, the only thing on the right side of that chart that really could be considered food would be the milk products, and that's only for infant mammals. We really are not supposed to be eating other birds and fish and mammals, and we shouldn't be eating birds' eggs. But again, when we do it, we have to pay a cost for it. So animal protein, I've covered all these things. It also have higher methionine content, which is self-containing amino acid, has been shown to promote cancer development and accelerate mitochondrial aging. So which type is better for humans? Clearly, animal protein is not healthy for us, causes cancer. It also damages our kidneys. It increases intraglomerular filtration pressure, accelerates kidney glomerular sclerosis, and has been shown in at least one study to actually cause chronic renal disease. But in many studies has been shown to increase the risk for progressing to end-stage renal disease and dialysis in people who already have kidney disease. It also damages the mitochondria in the kidney, interfering with the energy production, increases the acid load, and causes dysbiotic changes in the colon that increase inflammatory compounds in our bloodstream. Conversely, plant protein stabilizes, preserves, and improves renal function. Plant protein can actually reverse some types of renal damage. That I can tell you guys a lovely story about that at some point, but I don't want to take time to do it right now. But it has been shown over and over to help stabilize and improve kidney function, help people recover kidney function who have advanced renal disease, and to delay or even prevent progression to hemodialysis. Then this is what I call ghouls, food, and gaslighting. Animal ag is marketing the detritus of death. So one of the big pushes that they're out marketing now is colostrum. Colostrum is the initial fluid released from mammalian breasts once they deliver their babies. Colostrum is filled with antibodies from the mother, leukocytes, white blood cells, and other anti-infective compounds. But the point is that colostrum is species specific. Bovine colostrum contains antibodies against hoof and mouth disease and a whole host of things that cows get that we don't. So consuming bovine colostrum does nothing for a human being except clog up your arteries with fat and give you inflammatory proteins that you can't utilize. Moreover, bovine colostrum, the proteins in it are targeted to calves, and it has low fat and sugar content because sugar is not muscle fuel. Well, that's also important because proportionately, human babies have the biggest brains of any mammal, and they need a lot more sugar. And you're essentially kind of starving your baby's brain when you feed it cow's milk and cow colostrum. Bovine collagen is being marketed as a means of making better human collagen, which is stupid, because that's like telling people if you eat a cow's eyeball, it's going to give you better eyesight. It doesn't. Moreover, there's no need to go out and make a vegan facsimile of collagen. We don't need it. Our body is very good at taking the proteins from the plant foods we eat and reassembling them into the tissues that our body needs. You know, it never ceases to amaze me that people, you know, say, oh, I need meat to get protein, but they never deal with the fact that the cow didn't eat meat, but she has a lot of protein in her tissues. It's like, people, please think. And then bone broth is just absolutely disgusting because it is loaded with environmental pollutants, heavy metals, and other toxic compounds. Nobody should be eating that garbage. There is no need for any of this stuff whatsoever. All right, so let's look at iron metabolism. While iron is an essential element, it's dangerous. Excessive levels increase our risk of cancer, heart disease, and diabetes. So our body doesn't like to have a lot of iron laying around. And the thing is that our bodies can control the absorption of what's called non-heme or inorganic iron, the kind you find in plant foods. But our bodies cannot control the absorption of heme iron. Whenever your body sees heme iron, it will automatically absorb it. And that means that meat eaters who are constantly eating heme iron will always have higher iron levels than vegans because they're eating heme iron. So the question is, why are our bodies programmed to automatically absorb heme iron? Well, think about it this way. You're a plant-based organism. You absorb your iron directly from plant sources, and you're incorporating your tissue. Every day, we slough off, digest and reprocess the entire lining of our gastrointestinal tract. And so the body, being efficient, wants to, again, conserve as much of that material as it needs to. If it has already decided to absorb iron and incorporate it in its tissues, the logic is, this I'm going to hold on to because it's mine. Because our bodies never conceived the idea that we would be eating or consuming heme iron from an exogenous source. And that's why it will automatically absorb heme iron regardless of our iron levels. But when a person becomes plant-based and is no longer ingesting all of this heme iron, your body allows your iron stores to fall to a level where you're healthy and you're safe, but you don't have all of this excess iron laying around that can catalyze oxidative reactions that damage your tissues, damage your cell membranes, create cancer, mutagenic compounds, and so on. Research shows 12% increase in cancer risk for every 1 milligram heme iron ingested per day. And heme iron has been shown to increase pre-neoplastic lesions and other gene expression and cancer cells in ways that make tumors much more aggressive. And heme iron forms compounds that are toxic to normal cells, but not precancerous cells. And it catalyzes the formation of carcinogenic N-nitrosyl compounds found in processed meats. I would encourage everyone to watch this little video from Dr. Greger on heme iron. Now, this is a video on fiber from Michael Greger, nutritionfacts.org. I'm going to let that play, and then I'll be back with you in a minute.
In the US, we tend to get less than 20 grams of fiber a day, only about half the minimum recommended intake. But in populations where many of our deadliest diseases are practically unknown, rural China, rural Africa, they're eating huge amounts of whole plant foods, up to 100 grams of fiber a day or more, which is what it's estimated our Paleolithic ancestors were getting based on dietary analyses of modern-day primitive hunter-gatherer tribes and by analyzing coprolites, human fossilized feces. In other words, paleo poop. These most intimate of ancient human artifacts were often ignored or discarded during many previous archaeological excavations, but careful study of materials painstakingly recovered from human paleo feces says a lot about what ancient human dietary practices were like, given their incredibly high content of fiber, undigested plant remains, strongly suggesting that for over 99% of our existence as a distinct species, our gastrointestinal tract has been exposed to the selective pressures exerted by a fiber-filled diet of whole plant foods. So for millions of years before the first stone tools and evidence of butchering, our ancestors were eating plants. But what kind of plants? One way you can tell if animals are natural folivores or frugivores, meaning leaf eaters or fruit eaters, is to map the area of absorptive mucosa in our gut versus their functional body size. Folivores are those meant to eat mostly foliage, leaves, while frugivores are better designed to eat fruit. The faunivores eat the fauna, another name for carnivore. If you chart animals out this way, they fall along distinct lines. So where do humans land? Here's our functional body size, and here's our absorptive area. So while eating our greens is important, it appears the natural dietary status of the human species is primarily that of a fruit eater. Why does it matter how much fiber we used to eat? Well, one theory for the rising levels of obesity in Western populations is that the body's mechanisms for controlling appetite evolved to match how many plants we used to eat. Our ancestors ate so many plant foods, we were getting like 100 grams of fiber a day. So for millions of years, food equaled fiber. So no surprise, one of the physiological mechanisms our body evolved to suppress our appetite involved this fiber. For example, fiber is metabolized by our gut flora into short-chain fatty acids, which bind to and activate receptors on the surfaces of our cells that alter our metabolism. For example, activating receptors on fat cells to increase the expression of the weight-reducing hormone leptin. Other hormones are affected as well. Since until recently, food meant fiber. An increase in food intake meant an increase in fiber intake, which made our gut bacteria so happy they made lots of short-chain fatty acids, activating the cell surface receptors, releasing a bunch of hormones that make us lose our appetite and downregulate hunger, so we eat less. But if we eat less, there's less fiber in our gut, so less of these hormones are released, which boosts our appetite. We get hungry and we want to eat.
All right, I stopped that a little short because I'm running low on time, and I got to leave enough time for Geoff to do his presentation. I just want to skip ahead here and just talk about fiber and the microbiome. There is ongoing now mind-blowing and paradigm-shifting research being done on the human microbiome, showing how it influences, modulates every organ system and aspect of our health. So much of the work done heretofore on human health has not accounted for the role of the microbiome. Therefore, that work must be revisited, revised, and rethought. A wide variety of health problems we have long considered to be phenotypically discrete diseases may in fact be disparate manifestations of disordered microbiome in our gut. And if the scientists doing research on the human microbiome are studying the microbiomes of people eating predominantly animal and processed foods, by definition, they can never and will never arrive at the full truth of how our microbiomes can improve our health. With that, I'm going to stop and turn it over to my esteemed friend and colleague, Mr. Geoff Palmer.
Well, thank you for that presentation. I'm going to go ahead and get this PowerPoint pulled up here. Let's see if I can share screen. And first slide. And there we go. All righty. So obviously, as a natural bodybuilding champion at 61, the very first question most people ask is, where do you get your protein? Thankfully, Dr. Milton Mills has put that to the test, but it's part of the reason why I am a competitive athlete, why I formed the very first natural bodybuilding, vegan-only natural bodybuilding championship, is to show people what you can accomplish without using drugs and without consuming any animal products at all, even at the ripe old age of 60s. So, and beyond. This is me on stage, won first place in a master's physique over 50. This has been described, but I'm in my 40th year as a drug-free vegan. So 40 years, no drugs, and completely vegan. And in that 40 years, I have never consumed a single milligram of preformed DHA. So no DHA intake in 40 years. So obviously, thanks to plant-based news, I was selected number 40 overall, speaking of 40, as the most influential of vegans. All right, so my passion has been to try to get people to move away from animal products. And when I'm a compassionate or ethical vegan, so I care very much about the animals. It's why I became vegan back in 1985. But I really realized how could I have the biggest impact on animal life? And clearly, the number one most consumed animal in the world is fish. We've wiped out over 50% of all the marine life in the oceans, seas, lakes, ponds, streams in the last 40 years alone. Half of all aquatic life gone in just 40 years due to humans. Now, some of that is to climate change. Some of that is to the pollutions in the ocean too, oil spills, radioactive waste, all the rest of the things that humans are doing to destroy the planet. But 2 to 3 trillion fish are killed every year for human consumption, and it's not sustainable. We cannot keep doing this, so we have to find plant-based sources for it. So let's start with the basics of omegas. So there are only 2 essential omegas. It's the omega-6 linoleic acid and omega-3 alpha linoleic acid. Now, if you look at the chart below, you can see linoleic acid, the omega-6, at the top on the left-hand side, that is the first one that can convert down into all the other forms, including arachidonic acid. Then you have alpha-linoleic acid, more commonly known as ALA, and that converts down to all 6 forms, including DHA at the very bottom. Now, when we developed, Doctor developed the omega-3 blood test, red blood cell test. They were testing for how much ALA is converted in the bloodstream to DHA. Well, what they found was hardly any, less than 1%, and up to 1%, a little bit more in women, but a little less in men. And they're like, well, okay, well, then that can't be sufficient enough to supply the DHA that our brain needs. Okay, well, let's dive into that myth and why this doctor who developed the omega-3 got it so terribly wrong. All right, first of all, 90 to 100%, in my case, 100% of my omega-3 is in the human diet from ALA. So regardless if you're eating animal products or even eating fish, 90+% of all the omega-3 that your body intakes comes from plants anyway, because there's such a rich source of omega-3s in the form of ALA. So the requirements, the RDA for omega-3 ALA is 1.1 grams for women and 1.6 grams per day for men. But the average adult intake, this is average. This is what the average standard American diet is consuming, is 2 grams of ALA. So just on average, even if you're not vegan, you're getting more than enough ALA to meet all your needs for omega-3. All right. So what is the body doing with all that omega-3 ALA that we consume? Well, one of the first things it does is called beta oxidation, which is it actually uses it for energy. So it just burns it up, just like another fat. So some of that goes away, but a lot of it is stored in fat storage. Some of it is stored in the skin, and most of the ALA that is actually turned into active forms goes directly to the liver. Why is that? Okay, so we see now that our body takes fats that we need and stores them. So if you look at this is a graph of all the tissues taken from 58 different adult human males and females, so cadavers, and they looked at they analyzed all the different omegas in their tissues. And as you can see, the first 2 bars are white adipose tissue and brown adipose tissue. These are the 2 top fat tissues in our body. And that's where most of the ALA is going. So our body is basically saying, hey, that's good stuff. It's something that we can convert down into all the other forms. Let's just tuck it away in our fat cells and store it for a rainy day. Then if we're scarce in our diet, we're not getting enough input, we'll pull it out of the fat, convert it down to the form we need, including DHA, and then boom, we have enough supply. So our body's really good at storing a backup supply. You can see the second largest is the pink graph there, which is skin. So we store a lot in our skin too, because what gets damaged most often? The outside surface of the body. That's what runs into things, what gets cuts and scrapes. Well, it helps Amora to remediate injuries to the skin. So of course, that's a great place to store it. Plus you have fat in the skin, subcutaneous fat. That's a great place for it. But the next place on there, the next highest bar, the next amount of ALA stored is in the liver. It's the blue one right in the middle. Now, what you will see between right 2 bars over from the pink bar, the skin, is RBC. That is red blood cells. Do you see how much is in red blood cells? Practically nothing. Do you see how much is in the liver? Huge difference. The blue bar right there, right in the center, that's where all the ALA is going. Why is ALA not converting in the bloodstream, but all going to the liver instead? Well, there's a really good reason for that. But before we get into that reason, let's talk about how ALA actually converts down into all 6 other forms. Okay, so one, the top study on the top shows that ALA is a unidirectional conversion. So ALA goes to SDA, then ETA, EPA, DPA, and finally DHA at the very bottom. And there's a really good reason why DHA is the very last one at the bottom, because if you have all these enzymes, the body can turn on and off those enzymes, epigenetically control exactly how many and how much of each one of those forms the body has. And the one on the very bottom is the one you can control best, because you have 5 chances to stop the flow of conversion by changing epigenetics, turning on a gene to produce the enzyme that converts, or turning it off so it doesn't convert anymore. As a matter of fact, if you take DHA in its preformed state, like from fish or algae, and introduce it to the human body, the body thinks it produced its own. So it turns off the enzymes and starts piling up EPA, because it won't convert past EPA. It says, whoa, we've got too much. I don't need any more. Stop the enzyme conversion process at EPA. All right, so ALA provides all 6 forms of omega-3 all the way down the chain, allowing the body to convert the amounts it needs for each person, for each gender. Women convert at a higher rate because they have the potential of needing to feed a offspring. And if they got to care, they convert higher amounts of ALA to DHA so they can feed the baby. Higher amounts in specific tissues, as you saw that tissue chart before. Very little in the blood, very little in DHA actually in the skin, more ALA in the skin. So you can see the body chooses different tissues to convert different forms to, all the way down. If you give it its original precursor, the only essential omega, ALA, the body can then choose where to create that conversion process in the proper amounts. If you dump DHA in its preformed state into the body says, whoa, I didn't make that. That's in the wrong place. That's too much or too little. You're making an arbitrary guess about what the body needs instead of letting the body choose what it needs, how much it needs, where it needs it for each condition. So preformed DHA overrides our own body's beautifully eloquent, endogenously regulated system. This system is there for a purpose. And like Dr. Milton Mills just referred to earlier, that our body, just like every herbivore on the planet, converts ALA all the way down to DHA. Why do humans think we're different than every other animal on the planet? We're not. We're animals just like everybody else. Now, there is a difference. Carnivore animals like fish or tigers and lions, whatever, actually only started EPA. So they lost the first 3 steps because they're eating other animals that already have EPA and DHA converted. So they don't need to do that, and they're not getting ALA from their diet unless they eat the stomach of an antelope and have a little extra ALA in the plants that they've digested. But that's not what they're getting. So they actually just got rid of that. like he was saying, this is a conservation of energy. The body doesn't waste resources or energy on things it doesn't need. So carnivores got rid of the first 3 steps. Humans, like all other herbivores, have all 5 steps. Okay, so how much DHA does the brain actually use and need in a day? Well, the funny thing is that most people will say, oh, I take 250 milligrams a day or 1,000 milligrams a day. The actual requirement for the brain is less than 4 milligrams a day, 2.4 to 3.8, depending on your gender, per day. Now, catch this. When you autopsy a human being and you take all the fat out of their body and you find out how much DHA is stored, 20 to 50,000 milligrams of DHA is stored in our fat. That's enough to supply your brain for 20 plus years consuming no DHA. So we're overstoring this DHA. And that's because we can go for periods not eating a lot in nature and not eating sufficient amounts. So there would be fast, feast and famine periods in the wild. Our body protects that by storing extra DHA. Now, if the adult intake is 2,000 milligrams of ALA, that's average, if the average person, and only 1% of conversion, which is about what's happening in the blood, that would yield 20 milligrams of DHA, which is over 5 times the amount the brain actually needs for the day. And that's just what's happening in the blood. And that's not where most of the DHA is actually being converted from ALA. So let's take a look at that. All right, so the omega-3 index, which is the blood cell test, the red blood cells, measuring in this, which is the standard test. If you go into a doctor's office, they're going to give you the omega-3 blood test. They're going to take a blood sample, they'll look at your red blood cells and see how much EPA and DHA is in the blood. It does not measure ALA, and it does not measure ALA at its conversion spot, which is the liver. Now, interestingly, ALA can be taken right and absorbed directly into the brain and converted to DHA in the brain. So let's take a look at this 2009 study. So we've actually known this since 2009, that number one, the primary organ for converting ALA to DHA is the liver. I'll discuss why that is in just a second. And at 1,200 milligrams of ALA a day, when people are actually consuming 2,000 milligrams, the brain itself would produce enough DHA to supply the brain. So ALA going directly to the brain is sufficient enough to supply the brain with its DHA that it needs. Well, the liver actually converts ALA to DHA at 6 to 10 times that of what the brain produces. So you total up all the amount that's in blood, all that's happening, the conversion that's happening in the liver and in tissues and in the brain, and it's 30 times more than the brain actually can use, much less even needs. So the vast majority of the ALA that's being converted to DHA is actually getting stored in fat tissues anyway. So where did we get this idea that we're not getting sufficient conversion of ALA? Because we're measuring in the wrong place. We're measuring it in the blood, and this DHA conversion from ALA doesn't happen in the blood. It happens mostly in the liver, the brain, and other tissues. Okay, and why does ALA convert to DHA in the liver? So it can cross the blood-brain barrier. Okay, if you consume fish oil or algae or any preformed source of DHA, it's called triglyceride DHA or TAG DHA. This form of DHA cannot be used efficiently by the brain. The body then takes this DHA, if you look at the graphic there up in the upper left-hand corner, DHA comes in, and in the liver, it is attached to a lysophosphatidyl or LPC. And then the LPC DHA goes and attached to a transporter called MFSD2A. All right, too much science, I know. But it basically says once the liver turns it into LPC DHA, it can cross the blood-brain barrier and get into the brain and be used by the brain. So it's the LPC DHA that creates brain DHA, and that's what raises your brain levels of DHA. but it has to go to the liver first, which is exactly where ALA it gets transported to. That's why you do not see ALA converting into the blood. Why would it do that? It would go to the liver where it can be converted to DHA so that the brain can actually use it. Okay, so this is where we see. You can see this study, consistent with many prior other studies, higher ALA in the diet resulted in DHA concentrations that were only higher in the liver, not the blood. If you look at this, you can see DHA in the highest is in the brain. That's the brown bar there. The next highest is in the liver because it's being converted to DHA so it can get used by the brain. And then, of course, the green bar over there on the right-hand side is the spinal cord because it has similar tissues to what's in the brain, the nerve tissues. But look at that RBC. RBC is 3 spots over from the green bar to the left. RBC is red blood cells. That's the amount of DHA in the blood cells. Why would we think that that amount, that tiny little orange bar there showing practically nothing, is an indicator of how much is that brown bar in the liver or in the brain? It does not. It's silly. Okay, so we see here, this is the process of how TAG or triglyceride DHA, if you're eating fish oil or consuming algae oil, has to be transported to the liver. Hepatic lipase is the enzyme that the body mostly uses to convert that to LPC DHA so it can actually be used by the brain. So when you give somebody regular TAG, dietary-free DHA in the first highlighted section there, when you consume algae or fish oil, that TAG or triglyceride form of DHA, there is no effect on the brain in DHA content. None. Zero. So you can see at the bottom there, LPC DHA in the plasma is necessary for transport into the brain. That's why ALA goes directly, do not pass go, do not collect $200, go directly to the liver where it can be converted into LPC DHA. We're not measuring that conversion in the liver where most of this is happening. Okay, so this was a really neat study on BDNF, brain-derived neurotrophic factor. So DHA, once it gets into the brain, as well as ALA, once it gets to the brain, either DHA or ALA gets into the brain, it causes our body to produce a lot more BDNF. BDNF is actually what heals and repairs the brain. It's responsible for a lot of neuroactivity, the reforming and growing of new dendrites in our brain. It's the magic sauce. The DHA is just kind of helping upregulate it, giving it the nutrients it needs to do its thing, but it's the BDNF that provides all the magics, the cool stuff that we see, like improved memory, improved cognition, better intelligence, and IQ scores. Okay, if you look at the first graph on the left-hand side, you can see the TAG DHA is the DHA with the black dots, and that's how much is actually getting to the brain. Nothing. So that TAG DHA actually has to be converted to LPC DHA, which is what ALA does. Goes directly to the liver, gets converted to DHA. Now those are the red dots. You see how much more of those red dots are getting to the brain. Almost all of them in a really high level. So that fish oil, nothing to the brain. The ALA being converted to LPC, loading the brain with BDNF. So red blood cells is not a good reflection of how much is getting to the brain. It's actually the reverse. It's an inversion. The more TAG DHA in the red blood cells is telling you an indicator that it's not getting to the brain. We have it backwards. All right. So the human brain contains the highest amount of DHA, which is weird because the human brain only requires a minute little tiny little 4 milligrams of DHA per day. So what's all this DHA doing in the brain? Most of the DHA that is in the brain is structural. So once the body builds the brain with this DHA that makes up the membranes of the brain, the folds of the brain, the outer surfaces of the brain, it stays pretty consistent your whole life. That's why you only need 4 milligrams to go in and repair anything that got damaged or to replace DHA that's become oxidized or damaged. So when you look at human beings' autopsies from the age of 2 years all the way to 88 years, the levels of DHA in the brain basically do not change at all. It's consistent. So we took this assumption, oh my God, look at all this DHA that's in the brain. We must need a lot of DHA for the brain. No, it's structural. It's like saying, oh my God, look at all this calcium in the bones. We must need a lot of calcium for bones. No, unless you're getting rid of calcium, which is not a good thing, then you need to replace it. It's not that important. All right. So why DHA is not good for the blood and why the body does not convert ALA to DHA in the bloodstream. So the EPIC Norfolk study showed that the best conversion rates are by people who don't consume DHA, like myself. I have really high conversion rates because I don't consume it. So basically, if you're putting DHA, just if I were taking exogenous testosterone, my own body would shut down its production of testosterone. You're doing the same thing by throwing in some DHA. The body says, well, I must have made that. I don't need to produce my own. Shut down the process. So you're making your body less efficient at making its own DHA by adding DHA as a supplement. Okay, so you look at the bottom study. In conclusion, preformed DHA actually downregulates DHA liver synthesis. Now, this is the liver that is producing DHA for the brain. So by taking triglyceride form DHA, which you get from supplemental DHA like fish or algae, they're both triglyceride forms, you're actually downregulating your own body's creation of DHA that is built for the brain. So you're actually interfering with the process of the brain getting the DHA it needs. Okay, but it gets worse. This one is called the MACE study, and this one was really disturbing to me because it pointed out something that no other study had done. Most of the studies use fish oil, which have both EPA and DHA in them. And they said, well, wait a minute, EPA has some really positive effects on the cardiovascular system, but DHA not so much. What if we separated them, gave people only EPA or only DHA and see what happens? Well, they found out that higher levels of EPA, but not DHA, were associated with reductions of major adverse cardiovascular events like high blood pressure or heart attacks. Okay, that's a good thing. So EPA, great for the cardiovascular system. That's why ALA converts to EPA really fast and prevalently in the bloodstream. Plants got it right, and it stops there. Why? Because when you combine DHA with EPA, it blunts the benefit of EPA and increases your risks of heart attack and cardiovascular stress. So DHA is actually reducing the good EPA's positive effects on your cardiovascular and increasing your risk for heart attacks. Oh my God, it gets worse. DHA is known through multiple meta-analysis and reviews that it increases AFib, atrial fibrillation. Okay, what is atrial fibrillation? Atrial fibrillation is an irregular heartbeat. It is the most common arrhythmia or irregular heartbeat. How does it do this? DHA is known to increase membrane fluidity. Well, when you get too much water in the heart, it can't send this electrical signals to the heart and it gets squishy. You need a nice firm heart to do that heartbeat. So you're not pressing right, so it skips beats. And then you're also getting too much water in there, so this electrical signal to go pump doesn't get through. So you start skipping beats. Now, that's not good. But people say, oh, I know, but lots of people who live with AFib, no big deal. Oh, it's a huge deal. So this study, which is a systematic review and meta-analysis, the gold standard of studies, right? It's looking at all the research available and doing a review on it. They found that AFib increases heart attack risk by 63%. They said, well, if it's the case that it's messing with the heart, and we know the heart drives blood to the brain, is there damage being caused? And sure enough, there is. Because the irregular heartbeat, our brain, the tiny blood vessels in our brain need a regular, steady heartbeat. When it goes out of sequence, those blood vessels get too much blood and then not enough blood, and that expansion and contraction can cause your blood vessels in your brain to burst and damage. This is shown to increase, having AFib increases dementia and shrinking of the brain by 200%. So as a recap here, we've got DHA in the blood decreases your own body's production of DHA and decreases your body's ability to convert ALA to DHA. It increases LDL cholesterol. I've had people come to me and say, hey, wait a minute, I've been vegan for 10 years. My cholesterol is still high. I said, are you taking algae DHA? And he goes, yeah. I said, stop taking it. 3 months later, he contacted me back. Hey, it dropped 20 points. I said, yeah, it'll keep dropping too, because you've just removed the cause of what's creating that LDL. DHA is clinically proven to increase LDL cholesterol in the body. You don't need that. It increases MACE. It increases AFib, which can increase your risk for heart attack, and a 200% increase in dementia and brain shrinkage. Why on earth are we taking a preformed mimic of the animal's DHA and feeding it to people with all these negative side effects? It makes no sense. This is medical malpractice. It gets better because plants actually have phytonutrients and polyphenols in it. This one's done on a specific polyphenol, curcumin and turmeric, and together it increased the synthesis of DHA from ALA and elevated brain DHA levels. So just by taking turmeric, you can make your body more efficient. Plants make our body efficient at turning the plant ALA into DHA and getting it to the brain. How beautiful is that? The plants have all this set up for us perfectly. On the flip side, speaking of lipid flipping, this next study down below, that a high-fat diet actually lowers the level of DHA in brain because saturated fat blocks the transport system so the DHA can't even get into the brain. So by eating animal fats, you're actually reducing brain DHA levels. All right, well, what about omega-6 competition that we're hearing about? Oh, you're getting too much, omega-6, and that's competing with your, and like, no, that's not the case. This study actually showed that the conversion of ALA is not determined by the ALA-LA ratio at all. All it's determined about is how much ALA you're putting in the body. So they said, well, if that's true, then it'll be the true about arachidonic acid. And sure enough, they decreased the amount of arachidonic acid, which is omega-6, the pro-inflammatory. They decreased it in human diet 90%. And there was no change in arachidonic acid at all. So they said, well, we'll increase it. So they increased it 600%. They're basically giving straight seed oils to people to boost their arachidonic acid levels. No change whatsoever in arachidonic acid. Omega-6 LA or GLA does not increase arachidonic acid in the human body, decrease or increase. The same with DHA. The body really tightly regulates how much DHA and how much arachidonic acid is produced by the body. It does so because it wants to preserve it for the brain. The brain uses most of the DHA and most of the arachidonic acid. Now, people say, what about genetics? Okay, there are about 25 to 30% of the people who have genetic variations, or SNPs, they're called. Single nucleotide polymorphisms. They're changes in our DNA that over time could cause our bodies to convert the ALA less. All right, take a look on the left-hand side. You see the ALA converting to stearidonic acid, or SDA. That's called the rate-limiting step. That's the first step in the process. Now, those with ApoE4 or FADS2 genetic variations maybe not be producing as much of this delta-6 desaturase enzyme that will start the whole cascade process. So they do have an issue with less production. It's not absolute, doesn't knock out the whole ability. They just don't do it as efficiently. So that got me to thinking, my God, are there any plants out there that actually have not only the alpha-linic, the ALA that we need, but also have SDA in it? Because if you could bypass that step, that 25 to 30% of the population that don't produce this enzyme very well wouldn't have a problem because you've got it already pre-converted in the plant to SDA. And sure enough, that's where I found the research on Buglosoides arvensis. There was only one grower in the world at the time, and I was the very first to bring it to market. The trade name for it is ahi flower, and it is the richest source of SDA on the planet. Been multiple human studies showing SDA is far more effective at converting not only to from ALA down to DHA, but from SDA, even higher conversion to EPA and DHA in the body. So for those with genetic variants like ApoE4, FAS2 variations, those consuming ahi flower will get all of their needs met and don't have to worry about the genetics. As you can see, this compared to all the rest of those major sources of omega-3s, ahi flower is by far, or Buglosoides, its proper name, is by far the richest source of non-GMO source. You can see the GMO soybean. They actually genetically modified soybean to produce more SDA because of its effects. But you can see it in human test, head-to-head. It had a 4 times greater conversion rate to EPA in the bloodstream, where the body needs a lot of EPA. That's a good thing, but it then later converted from EPA down to DHA at a far more effective than flax oil or chia or many of the other sources at about a 400% greater rate. So that's the different things, but I want to talk about real briefly is, look, we have been hearing for so long, oh, you need preformed heme iron. Dr. Mills discussed why you don't need preformed heme iron. Oh, you need preformed vitamin A. No, you do not. Our body converts beta carotene in the skin tissues. Again, the very first look at that was conversion of beta carotene in the gut. Well, that's not where it converts. It converts mostly in the skin. Just like DHA, we were looking in the wrong place. Once we found that, we did this. So people say, oh, you need to get vitamin K2 because it's only produced by animals. No, how do animals produce it? They predominantly produce it in their microbiome, just like human beings do. And if you're feeding the body enough vitamin K1 from plants, the microbiome will convert all the vitamin K2 to it. Over and over again, carnitine, taurine, all these things that you say only come from animals. Yes, we're an animal. We make them too, just like the rest of the animals do. So I don't understand why we think that, okay, taurine doesn't, our body makes its own. Creatine, our body makes its own. Carnosine, our body makes its own. Cholesterol, our body makes its own. DHA, our body makes its own. Why are we stuck on this one nutrient thinking that we have to get it in a preformed state? We don't, just like every one of the other nutrients that animals make. We make them too. I don't get this, and it's been a frustrating experience because trillions of fish are dying for this misinformation created and manufactured by the fish oil marketing and now taken to the algae marketing. And I'm seeing vegans replicating the mistakes that animal eaters are doing by putting algae DHA in their body in a preformed state and causing potential health risks. That's why I'm so passionate about this. I think we need to get the science right because even some of the plant-based doctors out there, unfortunately, are pushing, preformed DHA. And my concern is the research is telling us that can be dangerous. That can cause health detriments to us. Why take that risk when our body doesn't need it? So I guess we can bring Dr. Hollie back on board and open up for questions.
Thank you, Milton. Thank you, Geoff. Geoff, I learned a lot. That was an excellent presentation on a difficult subject. As you said, it's been in the plant-based community, a lot of discussion, a lot of confusion. You did a very excellent job, elegant job of explaining that. So thank you very much. Natasha?
Yes.
We have time for a question or two?
Sure. And before I jump in, the chat has been so incredibly active. I do want to address this as a whole. Yes, folks, you will be receiving a replay. It will come to your inbox on November 13th. Do check your spam folder because it may end up there. There are lots and lots and lots of questions about all various types of supplements. I think the overall message and takeaway from this evening's webinar is these supplements are not necessary for plant-based eaters. Now, there may be, as the doctors have said, there may be some exceptions to that, and you can work with your healthcare provider to figure all that out, but I did want to address that. Additionally, people are asking for all the resources that were in the chat. We do compile resources that we send out with the replay email, so there will be some of those, but there won't be all of them. People are also asking if you can copy the chat. Go ahead and highlight it, right-click it, and you should be able to cut and paste it the old-fashioned way. So I'm sorry that I had to do that kind of housekeeping, but I think that hopefully will address a lot of these questions that are in the chat. But let's ask a couple questions that have come up over and over here. Are we ready? Let me see here. I apologize if I'm looking off to the side. I'm writing them all down. Okay. So there were quite a few questions on protein. And also on fiber, but this is a good one. How do you figure out how much fiber you're eating? You know, if you want to increase it, how do you know you're getting enough?
Sure. So number one, again, and I'm, you know, I don't know how clearly this came through. If you are eating whole plant foods, you're getting all of the fiber that's in those plants. And as I was, we had a little discussion right before the session started, and I was explaining that plants are as different as people, and each species of plant has a unique fiber profile, and the greater the variety we consume, the better. So how do you, the question is, how much of what you eat on a daily basis can be considered like, you know, a whole plant? You know, a lot of what people eat are like, you know, crackers or chips or you know, some prepared dish that is made from refined flour or something, which it has its fiber removed. And I also want to emphasize that one of the important points a lot of the books on the microbiome made is that Americans typically focus on bran fiber, okay, the roughage that helps push stuff through our colons, but that the most important type, and that's important, don't get me wrong, we need that too, but the most important types of fiber for actually making the short chain fatty acids and the neurotransmitters that modulate our immune system, improve our brain functioning, decrease risk for Alzheimer's. There's some evidence emerging that butyrate, a short chain fatty acid, can prevent amyloid plaque formation. I mean, I'm telling you, this topic is just amazing. That is done by action of our bacteria on the soluble portions of plant fiber. And that's why you got to eat the whole plant. You cannot get, you know, when you buy these artificial plant fiber products, you do not get that whole fiber profile. And so make sure that, you know, 60% of what you're eating is some form of a whole plant. I mean, a whole intact plant, which means that instead of juice, you put the whole a piece of fruit into the Vitamix and liquefy it if you want to take it that way. Or, you know, you grind your beans up and you make a loaf, or you make a burger, or just eat them as beans, but eat the whole plant and make sure you're getting the soft forms of plant fiber from your root vegetables, green leafies, and so on. And when you're eating enough fiber, you will poop at least once a day, and it's going to be a large poop. If you're like really, you know, hitting on all 12 cylinders, you'll probably be going twice a day.
Gotcha. Thank you so much, Dr. Mills. 2 more questions and then we'll wrap it up. So someone is saying, okay, if I've got digestion issues with beans, any suggestions on alternatives for protein? Because people think, okay, if I'm plant-based, that's going to be my main source of protein. What do I do?
So the thing with our microbiomes is that it takes time for your colon to train new workers. I mean, that's the best analogy I can come up with. That you open a factory, you want to make a product, but it takes time to train your workers. And what generally happens is that when people start changing their diet, the bacteria that are resident in their colons are those that are more gas producing than short chain fatty acid producing. And this primarily comes from these sugars that are in beans that we can't break apart and process, but when they pass through the colon, the bacteria have a field day. So again, as people say, soak your beans and then discard that water, cook it in a separate or fresh water. But the other thing that I always recommend to people is that when they're, in their first few months, to take Beano with their bean-containing meals. Beano is just a plant enzyme that breaks apart that sugar that we can't process, but when it's broken into its constituent molecules, it gets absorbed and excreted by our kidneys. So it's not available for the bacteria to make gas. So there are, and then there's also, people say put the sea vegetable combo in a pot of beans, and that helps reduce the gas as well.
Gotcha. Thank you so much. And then the last question is, so this person's saying collagen needs would increase in menopausal women as those levels of production dramatically decrease. Is this not a concern?
No. I mean, why would collagen levels increase? I mean, in a postmenopausal woman, that what changes in a postmenopausal woman is her hormone level, but the amount of she has the same tendons, the same ligaments, the same body structure. I'm not sure why this person thinks collagen needs or levels would change. Number one. Number two, our body makes collagen from the amino acids it extracts from the food that we eat. I showed you that slide that said vegans are getting 70% more protein than they need anyway. So even if your needs did tick up in terms of making collagen, let's say you're in a rollover car accident and you get some broken bones and torn ligaments and well, your need for collagen is going to go way up there. But again, you have enough of a buffer in terms of your amino acid protein intake that your body will just pull from that extra protein you eat every day and use that to repair itself. What I do recommend to my patients who say break a bone or something like that is to make sure you're increasing your vitamin C intake, because vitamin C is essential for making collagen.
Thank you very much. Dr. Hollie?
Mike, do you have anything to add?
No, I agree with you. I agree. I have one question for Geoff before we close. When is your book coming out?
So I've had some great input, obviously, from Dr. Milton Mills, who's graciously agreed to do the forward because we worked together on this project, sharing studies, but also other contributors like Dr. Tim Radek. If you don't know him, he is one of my favorite, who is totally aligned and has helped me with some of the research gathering too as well. We're still in the thing is, there's so much new research coming out almost on a daily basis on omega-3s that is really continuing to empower this story. There's new research out of the University of Toronto that just got published last month that shows 47 times more ALA conversion to DHA is happening in tissues than in the bloodstream. So we're way off, 4,700% off on this. And this study just came out. So the problems with the DHA research is that most of the research, like 90+%, is done on fish oil. and it's done on EPA and DHA, and it's preformed. They're not looking at ALA. They're not. They're just not. So one, they're not looking at standard. They're looking at standard American diet. So they're dealing with sick people who have higher requirements because they got more inflammation going on. Two, they're not including vegans in the studies, so they don't know what the baseline is. I look at these research and people say, oh, but what about this showing DHA did that? I said, compared to what?
Right.
That's the problem that they're having. They're all comparing to, oh, just a little bit more. So you're taking somebody from insufficiency or deficiency to sufficiency with a preform. Of course, you're going to see some benefits because now they have enough. But what if you gave them ALA instead? A great study just came out last year that showed, okay, they saw a 20% improvement in cardiovascular disease when they gave them fish oil. And they said, well, what happens if we gave them just more ALA on top of that, on top of being sufficient? And they got another 20 to 30% increase in improvements. So I'm like, well, they're not even including this in there. They're not even looking at what happens when you just add more ALA. And that's part of the problem, not including healthy people to get a baseline, not including vegans to see what that is about and how different they are to omnivore diet, and not including ALA at all. So it's been a real challenge to try to get the data, and I have to extrapolate using a lot of these studies saying, oh, I know what they're talking about here, but they're just looking at it the wrong way. Again, they're also looking at it with assumptions that EPA and DHA in a free-form state are better. They're not. Just like the assumption that heme iron is better, just because it absorbed faster. We now know that faster absorption can cause ferroptosis, right. The leading cause of type 2 diabetes. So no, that's not a good thing. It's a horrible thing. Yeah. So more is not better. Preformed is not better. The plant precursor states are better. They're just not looking at it in the data. So we really have to do a lot of data mining.
Yeah, can you quickly say something about ALA to DHA conversion intermediates and their impact on reducing migraine risk? Because that was one of the most powerful things that you had presented in one of your earlier talks on this topic. And I can tell you, I started recommending it to my patients when I was doing the outpatient clinic, and it works. I mean, it doesn't work for every single person. Nothing does. But for a lot of the patients, they found that when they did I would typically recommend flaxseed, and their bodies were able to, do what it wanted to do. It's like a little kid telling his parent, no, let me do it. That it actually did reduce their, the incidence and severity of their migraines.
Yeah, and part of that, look, I'm having a hard enough time just to explaining to people that there are more things than ALA, EPA, and DHA. When I get people to ask, like, what are the two omega-3s, they say EPA and DHA, and I'm like, no, those aren't even essential. Our body makes our own. So the vast majority of the public doesn't even know that there's 6 forms there, and that the body uses all of them for different purposes. And that's just stage 1. Each one of those ALA, SDA, ETA, DPA, EPA, and DHA all have their own specific what's called proresolvins or oxylipins. So these omegas actually break down into smaller, cooler particles that have even more pronounced effect. Now, ALA has its own set of oxylipins, just like SDA does. If you're consuming EPA down here, you're not getting the ALA, SDA, or EPA. ETA oxylipins, because they provide them only. If the conversion chart goes down, then you're only getting EPA, DPA, and DHA. So you're limiting the amount of different pro-resolving mediators. These are the really cool things, not just the base molecules. We need to start with just educating the consumers that, hey, there's 6 forms here, not just EPA and DHA. And that of those 6 forms, they even break down into cooler, different molecules called oxylipins that have tremendous effects. They even do that in the microbiome. So our microbes actually use essential fatty acids as a food source, and then break it down into these cool proresolvins, these things that neutralize and affect and cause chain reactions in our body to promote health we're not even talking about that yet. I could do a whole nother subject on just oxylipins. It's an amazing field of research that has just started to open up within the last 5 years. But that's how passionate I am about omega-3s. But we got to start somewhere. We got to get people to understand that these preformed sources are not necessary, just like none of the other preformed nutrients that people claim you can only get from animals is necessary. They're not.
Perfect. Perfect. Thank you, Geoff, for that explanation. Again, I learned a lot about omegas tonight, so thank you. And Milton, as always, thank you for your eloquent, you're excellent at explaining things. And as you guys are all saying, feed the body its whole foods and let the body do its work, quit trying to hijack it, So on behalf of the T. Colin Campbell Center for Nutrition Studies, we thank you, Milton and Geoff. I thank you, everyone, for joining us. And until next time, have a good evening.
Thank you, Mike. Thank you, Natasha.
Thank you for having me.
Take good care. Thank you so
right.
much.